Is it okay, sir?
Yes, sir. Your face not visible.
My video?
Yes, sir.
Wait a minute. Okay.
Now, okay, sir.
Thank you.
Good evening, everyone. We welcome you all for the day 3 on our 5 days SPSS program in research. So, Kumaresan sir,
Yes.
you can
Shall we
continue.
start?
Yes, sir.
Yeah, thank you. There is a video visible. Very good evening, Dr. Sekhar sir and his team, and all the participants. I hope this day and this session would be very useful for all of us. Today's discussion is about ANOVA and MANOVA. What is ANOVA and what is MANOVA? You know, we have heard about ANOVA. But what is MANOVA? I have stopped the screen sharing. I will start once again after a small introduction. Okay. Right. So ANOVA is a parametric test. Then what is MANOVA? MANOVA is also a parametric test. In the parametric test, we have discussed about, in the previous batch, what are the parametric tests? Parametric tests are basically classified into two, t-test and ANOVA. T-test is again divided into three. That is, one sample t-test, independent samples t-test, and paired samples t-test. ANOVA is classified into two, one-way ANOVA and two-way ANOVA. Okay. Now, what is ANOVA? Where should it be applied? ANOVA means analysis of variance. What is variance? It is one of the parameters. It is very simple. Variance is the square of standard deviation. So if you square the standard deviation, you will be getting the variance. In the t-test, There are three t-tests I told you. One sample t-test, independent sample t-test, and paired samples t-test. In the t-test, the comparison is made between means. Parametric tests are basically using certain parameters. If parameters are used, we call it as parametric test. What are the major parameters? Mean, standard deviation, and variance. Mean we know pretty well. Standard deviation we know. But what is variance? Variance is the square of standard deviation. In the case of ANOVA, analysis of variance, we are going to compare the variance of the groups. Here we have one independent variable and one dependent variable. ANOVA is divided into two, basically. I told you no. One-way ANOVA and two-way ANOVA. In the case of one-way ANOVA, there is only one independent variable. In the case of two-way ANOVA, two or more independent variables. Here the condition is the dependent variable must be scale data. Okay. Dependent variable must be scale data. What about independent variable? Independent variable is a categorical variable. Or we can say that it is nominal variable. Nominal data. That independent variable is divided into how many categories or how many groups. If there are only a maximum of two categories or two groups, either one group or two groups, we have to apply t-test. If more than two categories are there, for example, we are taking gender. Normally it is divided into two, male and female. Nature of family, joint family and nuclear family. Or sometimes marital status, married, single. In these cases, there are only two groups. If there is only one group, we have to apply one sample t-test. If there are two groups, that two independent, we have to apply independent samples t-test. Then third one, paired t-test. Only one group. The samples are not divided into groups, but the data are collected for two different periods, before and after, pre and post. Like that, if the data are collected or if the data are given, in that case, we have to apply paired t-test. So one sample t-test, no categorization. Entire sample is considered as a single group. So we call it as one sample t-test. If there are only two groups, like boys and girls, married and unmarried, joint family and nuclear family, there are only two groups. If we are comparing, we can apply independent samples t-test. While discussing about the correlation, I told you n should be equal. But here, n of group 1 may be different. N of group 2 may be different. They need not be equal. There are 5 boys and 7 girls. 5 and 7 are not equal. In the correlation, 10 fathers, 10 sons. Here, 5 boys, 7 girls. N is different. Independent. Two samples are independent. So we applied independent samples t-test. Only one sample, no categorization. But two different data. Paired samples t-test. Here, we compare means. In the case of one sample t-test, population mean and sample mean are compared. In the case of independent samples t-test, sample 1 mean and sample 2 mean are compared. In the case of paired samples t-test, sample mean before and sample mean after are compared. But when we come to the ANOVA, we are going to compare the variance. That is why the name is analysis of variance. Here, the condition, dependent variable must be scale data, that is okay. Here also the same condition. Regarding the independent variable is divided into more than 2 categories. For example, residential area, urban, semi-urban, and rural. So there are 3 categories or 3 groups. Male and female, 2 groups only. If there are only 2 groups or 2 categories, independent samples t-test is to be applied. If more than 2 categories are there, urban, semi-urban, rural, educational level, up to school level, UG level, PG level, others. 4 groups are there. Occupational status, employed, businessman, professional, suppose student, housewife, like that. So more than 2 groups are there, more than 2 categories are there. In that case also, we can apply the one-way ANOVA. One-way ANOVA is to be applied where there is only one independent variable. Please understand, one independent variable that may be divided into different groups, different categories. I told you, more than 2 categories. More than 2 categories doesn't mean that more than one independent variable. The variable is area of residence. So only one independent variable. That independent variable is divided into three categories. So what is it? Urban, semi-urban, and rural. Okay. Here also, the n need not be equal. For example, 5 rural people are there, 10 urban people are there, 6 rural and semi-urban rural people are there. No issues. Need not be equal. Which is greater, which is lower? No issues. Any number. In that case, if the dependent variable is scale data, dependent variable is scale data. Independent variable is categorical. Categorical means either nominal or ordinal. In that case also, we can apply one-way ANOVA. For example, we are taking the age as an independent variable. We have collected the age as a continuous scale, like up to 20 years, 20 to 40 years, 40 to 60 years, above 60 years. Here, it is given in ascending order, up to 20 years, 20 to 40 years, 40 to 60 years, above 60 years. So continuous series, but it is given in order. So we call it as ordinal data. Ordinal is also categorical. That may be given either in ascending order or in descending order. That is immaterial. I told you about the educational qualification. Up to school level, UG level, PG level, and others. Can it be regarded as ordinal data? It cannot be regarded as ordinal data. School level, okay. UG level, it is in the ascending order, okay. PG, again in ascending order. But when we come to others, others may be illiterate, others may be diploma or ITI or even PhD, is it not? So illiterate, ITI and diploma are below the level of UG, below the level of PG. If below the level of PG is given at the end, after the PG level, we cannot say that it is in ascending order or in descending order. We cannot say. So, educational qualification cannot be regarded as ordinal data because others is the last option. Regarding the occupational status, it is categorical but nominal. There is no ascending order or descending. Like area of residence, place of dwelling. Here also, there is no ascending or descending order. So they are called nominal data. So both nominal and ordinal are considered as categorical. What is the difference? In the case of ordinal, the categories are given in either ascending order or in descending order. That's all. So that is the difference between nominal data and ordinal data. Here in the case of one-way ANOVA, independent variable may be ordinal data or nominal data. But what is the condition? Dependent variable must be scale data. That's all. And as I told you, numbers need not be equal. N need not be equal. Okay. Suppose if there are two independent variables or more than two independent variables, then we have to apply two-way ANOVA. We have to apply two-way ANOVA. In that case, suppose if one of the independent variables contains more than two categories, one of the independent variables contains more than two categories, and another independent variable contains only two groups, then no issues. We can apply two-way ANOVA. Earlier I told you, if there are only two groups, we have to apply independent sample speed test. In that case, there was only one independent variable. But here, two independent variables are there. One independent variable contains more than two groups. Another independent variable contains only two groups. In that case also, we can go for two-way ANOVA. So here, the comparison is made between variances. What are the variances? Or what is the variance? Variance is the square of standard deviation. So obviously, standard deviation is the square root of variance. That's all. Now, we'll go to the problem. So look at here. There are three food delivery service providers: Swiggy, Zomato, and Uber Foods. The overall satisfaction of customers, of 30 customers, towards the services provided by them was obtained. And the overall satisfaction scores were as follows. So here, two data are given. You are required to examine whether there is any significant variation in the overall satisfaction of customers in accordance with the food delivery service providers. So satisfaction is the dependent variable. Service provider is the independent variable. This independent variable is given as nominal data. So only names are given. Only there are three categories: Swiggy, Zomato, and Uber Foods. Since there are three categories, we have to apply ANOVA. So one-way ANOVA or two-way ANOVA, only one independent variable. This is independent variable, and overall satisfaction score is the dependent variable. Dependent variable scores are given. So it is scale data. Independent variable is nominal data. So we have to apply one-way ANOVA. Before that, we write the hypothesis, null hypothesis. There is no significant variation in the overall satisfaction of customers of food delivery service providers. So alternative, obviously, there is a significant variation. That's all. Only one word is different. There is no significant variation. Here, there is a significant variation. Okay. After having written the hypothesis, we'll go to the analysis. So here, what are the variables? Overall satisfaction and food delivery service providers. Okay. I mean, satisfaction score is given here. So go to analyze. Go to analyze. Go to compare means. Go to compare means. Then select one-way ANOVA. So in the menu bar, we can find analyze menu. Select analyze. You can find a drop-down menu. In that menu, you can find compare means. A sub-menu appears. In that menu, you can find one-way ANOVA. So click that. A window appears like this. Only the dependent list is given. Here, the independent variable is called as factor. So it is called as factor. So the overall satisfaction score is the dependent. Food delivery service provider is the factor. That's all. So there are two variables. One is overall satisfaction score. That score is given as scale data. Service provider is given as nominal data. There are three groups. So we go for one-way ANOVA. For one-way ANOVA, we go to analyze, then compare means, then one-way ANOVA. In the one-way ANOVA, we have selected the overall satisfaction and we have brought it to the dependent list. What is factor? The independent variable is the factor. So you click on OK. That's all. Only one box is given, or only one table is given. In the case of regression, we find that there are 4 tables. But here, there is only one table. Yesterday, I told you, while analyzing or performing the regression analysis, one of the outputs was ANOVA table. In that case, this one, this one was given as, wait a minute. See, here it is there. Earlier, it was given as regression and residual. Yesterday itself, I told in the case of ANOVA generally it will be between groups and within groups. So here we are comparing the variances. That is why we call it as ANOVA. Analysis of variance. Sir, what is between groups and what is within groups? Look at here. For that, let me show the frequency. Go to descriptive statistics, go to cross tabs. In the cross tabs, there will be more items. Okay. This overall satisfaction maybe in the column and maybe in the row, and service provider maybe in the column. Okay. Look at here. Swiggy, Uber Foods, and Zomato. So 29, 37, 39, 41, 43, 48, 49, 51, 52. Now, there are three groups. Group 1, Swiggy. Group 2, Uber Foods. And Group 2, Zomato. This between groups is meant for the differences between these groups. Group 1, Group 2, and Group 3. Then what is within groups? The difference in the group among the Swiggy, among the Uber Foods, among the Zomato customers. If the variance of three groups are compared, variation between Swiggy customers, Uber Foods customers, and Zomato customers are compared, it is said to be between groups. If suppose that variation among the customers of Swiggy, among the customers of Uber Foods, among the customers of Zomato. See, look at here. Just for example, the Uber Swiggy, 29 score, no customer. Uber Food, 1 customer. Zomato, no customer. 37 score, 0, 0, 1. 39, 1, 0, 0, like that. So in some scores, 1 is available, 2 is available, or 0 is available between groups. Look at here, within groups, 29, 0, 37, 0, 39, 1, 41, 0, 43, 0, like that. So if comparison is made between groups, then this one. If the comparison is made within groups, then this one. So here, the variance is calculated. And the sum of squares are given. Okay. Then degrees of freedom. The first one is called V1. V means degrees of. This one is known as SS1. Sum of squares 1. This is sum of squares 2, SS2. This is V1 and the 27 is V2. 29 is V3. 21, V1. What is V1? 2. We can cross check whether 2 is correct or not. How many groups are there? 3 groups. Groups are given in columns. How many columns are there? 3 columns are there. 3 columns are there. So V1 is C minus 1. V1 is C minus 1. There are 3 columns. So C is 3. 3 minus 1, 2. So that is V1. V1 equal to C minus 1. Then V2. V2 equal to N minus C. What is N? 30. N is 30. What is C? 3. So what is N minus C? 27. So V2 is 27. Then come to V3. V3 is N minus 1. So here V1 equal to C minus 1. V2 equal to V2 equal to N minus C. N minus C. What is V3? N minus 1. V3 equal to N minus 1. That's all. Look at here. So V1 equal to C minus 1. Number of columns minus 1. V2 is equal to number of items minus number of columns. V3 equal to number of items minus 1. Okay. This one is SS1, SS2. V1, V2. Then this is MS1, MS2. MS1 equal to SS1 divided by V1. Then MS2 equal to SS2 divided by V2. What is F? Yesterday I told you, no, MS1 by MS2. MS1 divided by MS2. So I showed yesterday using calculator. Look at here. First one. MS1 equal to SS1 by V1. What is SS1? 576. 0.817 divided by 2. 288.409. We got it. Then what is SS2 3004.683 divided by 27. We get 111.285. Then 288 V MS1 divided by MS1 divided by MS2. .592. That is F value. Okay. This is how we can cross check whether the output shows the correct values or not. Then come to the P value as usual. What is P value? It is 0.093. It is greater than 0.05. How to decide? P value means probability value. P value means probability value. Probability means chance of happening. Chance of happening means chance of accepting null hypothesis. Chance of accepting null hypothesis. Look at here. What is level of significance? 5%. That is 0.05, not 0.5. Please, dear friends, note it. It should be 0.05. It should not be 0.5. Sometimes in hurry, we take it as 0.5. That is why I am telling 5%, 5%, 5%. 5% means 5 by 100. So obviously it is 0.05. Okay. Probability value is greater than 0.05 means the chance of accepting the null hypothesis is more. If the P value is more than 0.05 or greater than 0.05, the chance of accepting the null hypothesis is more. If it is more, accept it. If it is more, accept it. So if you accept the null hypothesis, what is the conclusion? Sir, there is no significant variation. So here the result is not significant. So interpretation and findings should be given differently. Unfortunately, many scholars just copy and paste both the interpretation and the findings look like the same. See here, I'm telling you, there is no significant variation in the overall satisfaction since the p-value is greater than 0.05. This is interpretation. What is conclusion? It is concluded that the satisfaction of the three service providers did not vary significantly. The satisfaction did not vary significantly means the services of the three providers have made no significant difference. All are like same. What this one is doing, the other service provider is also doing the same. Sir, why this is done, sir? If suppose you are the marketing manager and you have collected data and analyzed, you have got this result. Now, you should offer suggestion to your MD, to your employer. If you go and tell him, sir, all are same, sir. No difference, sir. That any layman can say. But as a researcher, what should you tell your management? Sir, all the companies, all our competitors are having similar satisfaction. Our services have given similar satisfaction among the customers. This is the right time for us to provide value-added services more than our competitors. More than our competitors. It is the suggestion given to the MD as a marketing manager. As a researcher, you have to offer suggestion. That suggestion should be specific, not general. See, normally, what are the delivery boys doing? They are going to the particular restaurant and bringing the parcel. It is kept in a large bag. Then it is delivered at the doorsteps of the customers. Whether the bag is cleaned properly, whether it is hygienic, we do not know. Sometimes, see, regular customer is different. Casual customer is different. As far as the regular customers are concerned, we have to provide more value-added services. You can provide a separate carrier like tiffin box, tiffin carrier, or separate hot box, because that bag is a large bag. Any number of container can be kept inside. So if you give suggestion like this, that is appreciated. So here also, we are giving findings in a different manner. Then we are offering suggestions. This is about one-way ANOVA. One-way ANOVA. So here, now, there is no significant difference in the satisfaction of customers of three service providers. Even though there is no significant difference, I told you, no, we are not saying that there is no difference. There is a difference. But the question is whether it is significant or not. That is the question. Whether it is significant or not. Sir, how to check it, sir? Go to data. Then analyze. analyze. Go to descriptives or go to compare means. Go to compare means. Dependent list. Overall satisfaction score is the dependent list. What is independent list? Service provider. Go to options. Mean, number of cases, standard deviation, minimum, maximum. If suppose you want variance, you can include. Some scholars do not know the significance of kurtosis and moments. They are including kurtosis and skewness also they are including. Okay. See, number of cases may be taken to the top. Suppose percentage is also to be included. You can include it here. So number of cases, percentage of total N, mean, standard deviation, minimum, maximum. Kurtosis and skewness not necessary. I just showed you some people are doing like that. Okay. Now continue. Then click OK. Look at here. Swiggy. There are 12 customers. There are 12 customers. Uber Foods, there are 11 customers. Zomato, there are 7 customers. I told you, no, N need not be equal for the 3 categories. So 12, 11, and 7. They are different. Then percentage to total N. Total N 30. So 12 by 30 into 100, 40%. 11 by 30 into 100, 36.7%. 7 by 30 into 100, 23.3%. Okay. Now what is the mean score? Swiggy, 60 point. Look at here. Swiggy, 60.8. 60.08. Uber Foods, 50.09. Zomato, 56.14. So the overall mean is 55.50. But the individual average scores are different from one group to another. So the highest mean score is for the Swiggy customers. Second highest, Zomato. Lowest mean score, Uber Foods. Suppose you have compared as a researcher, you have compared all the 3. Your suggestion should be for Uber Foods because that customers have the lowest satisfaction score. Look at here, the minimum and the maximum. I told you the significance of minimum and the maximum yesterday itself. It determines the standard deviation. 39.72, 29.67, 37.68. See, the minimum score, very lowest, 29 only. For the Swiggy customers, it is 39. For the Zomato customers, it is 37. So here it is lowest. The maximum score also 72, 68, 67, lowest. But you look at the standard deviation, it is very higher. It is very higher. That is why the mean score is very less. That's all. So this is about one-way ANOVA. Then we will go to the two-way ANOVA. I told you, no, if there are more than one independent variable and one dependent variable, now there are three variables. Earlier only two variables, service provider and satisfaction score. Here, Star Electronics sells its products through dealers and distributors appointed in 4 different zones: east, west, north, and south. The annual turnover made by 30 of its dealers and distributors. So the type of retailer, there are two types of retailers. One is dealers and the other is distributors. There are 4 zones: east, west, north, and south. The annual turnover of each retailer is given. Okay. It is given in rupees. So it is a scale data. Dependent variable is scale data. Now there are 2 independent variables. Zone contains 4 categories: east, west, north, and south. There are four categories. More than 2. More than 2 means we have to go for ANOVA. One way or two way? Two way, because one more independent variable is given. That is type of retailer. But the type of retailer contains only 2 categories. No problem. Since one of the independent variables contains more than 2 categories, better you can go for ANOVA. Since there are 2 independent variables and the dependent variable is scale data, we go for two-way ANOVA. See here, this type of retailer is given as a categorical data. That is nominal. Zone is also nominal. Zone is also nominal. I told you, no, it may be nominal or ordinal. Here both are nominal. Now question. You are required to examine whether there is any significant variation in the annual turnover of the company according to retailer and zone. Since there are 2 independent variables and 1 dependent variable, we have to apply two-way ANOVA. Here also, the numbers may be different. Number of dealers and the number of distributors need not be equal. Number of east zone retailers, number of west zone retailers, north zone retailers, south zone retailers need not be equal. Okay. Now we have understood only one dependent variable that is given in scale data. There are 2 independent variables. They are given in nominal or categorical data. One of the independent variables contains more than 2 groups. So better we can go for two-way ANOVA. Okay. Now we will go to the data. Go to analyze. Go to analyze. Go to general linear model. Go to general linear model. Select univariate. What is the dependent variable? Here, turnover is the dependent variable. Annual turnover. Then, what are the independent variables? Type of retailer and zone. They are the factors. The two fixed factors. Annual turnover is the dependent variable. Type of retailer and zone are independent variables. We call it as fixed factors. But before that, we have to do one more thing now. What is it? We have to write the hypothesis. Earlier, there was only one independent variable. So we have written one hypothesis. Here, there are two independent variables. So we have to write two hypotheses. Is it correct? No. We have to write three hypotheses. One is about type of retailer. Another is about zone. Another is about both. We call it as interaction. Look at here. There is no significant variation in the annual turnover according to retailer, according to zone, according to retailer zone interaction. So obviously three alternative hypotheses. Okay. Now we will go to the analyze. Analyze. Once again, I'm repeating. Go to analyze. Go to GLM, general linear model. Select univariate. What is the dependent variable? Annual turnover. Okay. What are the independent variables? Type of retailer and zone. Now, one thing is implied or can be understood from this window. Look at the box size of the dependent variable. It can accommodate only one variable. Can accommodate only one variable. And moreover, at the top of the box, it is mentioned as dependent variable. Dependent variable. So only one dependent variable must be there. But look at the independent variable or fixed factor size. It can accommodate any number, any number. See, just for your understanding, I am giving this. It is accommodated. It is accommodated. It is accommodated. Is it not? So any number can be accommodated. But in the case of dependent variable, only one can be accommodated. See, suppose I am adding one more thing. No. See, look at this arrow is disabled. And here it is shown as dependent variable, not dependent variables. It is not given in plural form. It is given in singular form. It means there should be only one independent variable. But here this arrow is enabled. So any number can be added. That's all. Now we click OK. Again, there are two tables. Right here. This is the result. Test of between subjects effects. First one, corrected model. Second one, intercept. Intercept like regression, it is also constant. Come to retailer, zone, and retailer come zone. Come to the p-value. Here we need not bother about the other values. Straight away we are coming to the p-values. What is the p-value here? Look at this. For retailer, p-value is 0.569. 0.569 means it is greater than 0.05. If it is greater than 0.05, there is no significant variation in the annual turnover of Star Electronics according to type of retail. So retailer wise, there is no significant difference. There may be difference, but that difference will be very meager. It is not remarkable. Significant means remarkable. It is not remarkable. Whereas in the case of zones, look at the p-value. It is 0.000. So it is less than 0.01. So we say that the result is significant at 1%. Look at here. Since the p-value is less than 0.01, there is a significant variation in the annual turnover of Star Electronics according to zone. But when we come to the interaction, once again, the p-value is 0.332. It is greater than 0.05. It is greater than 0.05. If it is greater than 0.05, once again, we say that it is not significant. So here, since the p-value is greater than 0.05, there is no significant variation in the annual turnover of Star Electronics according to interaction of retailer and zone. Okay. Now, you look at the results. One more table is given. That is just numbers. Look at here. There are 15 dealers and 15 distributors. N of both the categories is equal. That is not required. Whether it is equal or not, we need not bother. Similarly, here, analyze general linear model, univariate, type of retailer, zone, go to zone. Zone. One is east, second is west. Third is north. Fourth is south. Now we go to analyze general linear model. Sorry. univariate. Now look at this. So east zone, there are eight retailers. West zone 7, north zone 7, south zone, north zone 8, south zone 7. They are different. They need not be equal. So here what we conclude, it is concluded that the annual turnover of Star Electronics varied significantly among the 4 zones. See the difference between interpretation and findings or conclusion. Okay. Now one more question. Sir, whether dealers have performed better or distributors have performed better. Again, go to analyze and compare means. Annual turnover is the dependent. Retailers independent. Zone is also independent. But we want to compare. Okay, leave it. Number of cases, mean and standard deviation. Click OK. Look at this table. See, the mean turnover of dealers, 54.8 lakhs. Distributors, 49.87 lakhs. Whereas you come to zones, East zone, 61.3 lakhs. West zone, very, very low. There is a vast difference between East and West. 28 lakhs. North, 40 lakhs. South, 80 lakhs. South, 80 lakhs. That is why we got the result that there is a significant variation in the turnover according to zones. So the turnover of Star Electronics varied significantly among the 4 zones, but not among the retailers. Not among the retailers, because it is 54, it is 40, just 4 lakhs or 5 lakhs difference. That's all. But here 61 lakhs, 28 lakhs. So some 33 lakhs. Again here 12 lakhs. Here 80 lakhs. Okay. Sir, what suggestion we can offer, sir? See, for whom we have to offer suggestion means, for West Zone we have to offer suggestion. Because they have the lowest turnover. If suppose you are offering suggestion to the MD regarding the improvement of performance, you should compare the best performer and the least performer. Who is the best performer? South. Their turnover is 80 lakhs. West zone has got only 28 lakhs. So we can offer suggestion, or we can suggest to the management for improving the performance. We can say the West Zone retailers may be asked to adopt the strategies adopted by South Zone. One suggestion. Another suggestion for improving the performance. We can ask the West Zone retailers to go to the South Zone retailers and get some training from them, so that also the performance or turnover of West Zone could be improved. Or otherwise, we can ask the West Zone retailers what was the problem, whether there is any competitor, or whether there is any dissatisfaction among our customers in the West Zone. So there are scope for further research. So further research is to be carried out and find whether there is any impact of competitors on the West Zone retailers, or whether the satisfaction level is less among the West Zone customers. Okay. But this is for improvement of the performance. One more suggestion I told you, no, for cost cutting. For cost cutting. Because the management will always be looking for cost cutting. You can suggest with a hard heart that the West Zone retailers may be withdrawn. They may be closed. What to do? Cost cutting, no. They are spending more and turnover is not up to the level. So let us close the retail shops there. Why should we continue? Is it not? So this kind of suggestions could be offered as a researcher, as a marketing manager to the MD. So this is about two-way ANOVA. Only one dependent variable, two or more independent variables, one of the independent variables, or even both, may be containing more than two groups. More than two groups. Then we can go for two-way ANOVA. We have to write three hypotheses. One is for one independent variable, one is for another independent variable, and the third one is for both independent variables together. Interaction means together. Then we go to analyze general linear model. Is it not? Then univariate. We have to select a dependent variable and fixed factors. Fixed factors are the independent variables. So with this box itself, we can understand there can be only one dependent variable, but any number of dependent variables may be there. So that's all about the two-way ANOVA. Now we have completed ANOVA. What about MANOVA? See, I stressed you, I emphasized you that there must be only one dependent variable. There must be only one dependent variable. Thus, that must be scale data. But whereas in the case of MANOVA, M stands for multivariate analysis. Whenever we have M, even tomorrow, we are going to discuss ANCOVA and MANCO. A means univariate. M means multivariate. ANOVA, univariate. MANOVA, multivariate. ANCOVA, again, univariate. MANCOVA, multivariate. Sir, what is univariate? What is multivariate? In the case of univariate, only one dependent variable. In the case of multivariate, there are two or more dependent variables. There are two or more dependent variables. That's all. Here also, there must be two or more independent variables. If we discuss about ANOVA, I told you, no, ANOVA, one way ANOVA, one independent variable, one dependent variable. Two-way ANOVA, two or more independent variables, one dependent variable. In the case of MANOVA, there may be any number of dependent variables and any number of independent variables. See, earlier, one-way ANOVA, we had only two variables, service provider and satisfaction score. Satisfaction score is dependent variable that is given in scale data. This is independent variable given in nominal data. When we come to two-way ANOVA, there are three variables. Annual turnover is the dependent variable given in scale data. These are independent variables. Type of retailer and zone, they are given in nominal data. Come to the MANOVA. Here, the following are the scores obtained by 30 students of your college in corporate laws and auditing. There are two subjects. Marks are given. We are going to compare. You are required to examine whether there is any significant variation in the marks obtained by the students in the two given subjects with reference to gender and specialization. So there are two independent variables, gender and specialization. There are two dependent variables, marks in corporate law and marks in auditing. These two are dependent variables and are given in scale data. Gender and specialization are independent variables. They are given in nominal or categorical data. Gender has two categories, male and female. Specialization has three categories. Okay. So how to proceed? Go to the data. Now look at the specialization. Three specialization: finance, marketing, and HR. Then the gender. One male, two female. So both are nominal. Marks are scale data. Marks in corporate land auditing, they are scale data. Okay. Now go to analyze. Again, general linear model. Earlier for two-way ANOVA, we selected univariate because there was only one dependent variable. Now we have to select multivariate. Now look at the size of dependent variables box. Earlier, analyze, general linear model, univariate. Look at here. This is univariate. Univariate is for two-way ANOVA. Look at the box size. Only one variable can be accommodated. But look at the size of this box, any number. Here, look at the fixed factors box, any number. Here also, any number. So this box size itself implies the number of variables to be accommodated. That's all. Again, look at here, dependent variable. It is given in singular form. But here, dependent variables. Dependent variables. It is given in plural form. It is given in plural form. That's so. Let us have the dependent variables. What are the dependent variables? Marks in corporate accounting and marks in auditing. They are dependent variables. Then gender and specialization. They are independent variables. Now click OK. Now look at here. General linear model. The results contain three boxes. Okay. First one, as usual, numbers. 15 males and 15 females. Equal, need not be equal. If it is equal, then okay. May or may not be equal. Look at here. 12 finance students, 11 marketing students, and 7 HR students. Okay. See here, this is multivariate test. There are 4 tests. Wilder's trace, Wills lambda, Hotling's trace, and Roy's largest group. There are 4 tests. Wilder's trace, Wills lambda, Hotling's trace, and Roy's largest group. Anyone can be chosen. There is no problem at all. You are given both. You are given the results of all the 4 tests. And one thing you should know, the results of all the 4 tests need not be the same. Sometimes it may be somehow different. Some differences may be there. among the results of 4 tests. See here, the effect is intercept, gender studies, specialization, then both. Come to this one. This is the final result. Look at here, intercept is okay. Then come to gender studies. Look at the p-value. Marks in corporate law. In corporate law. P-value just for showing the this one, I am deleting this column. Sometimes or I will show here itself. Okay, don't bother about it. The gender of students. The p-value is 0.000. 0.000. So it is less than 0.01. That means marks in corporate laws obtained by the students are significantly different according to the gender. According to the gender. Similarly, marks in auditing, the p-value is 0.001. That is also less than 0.01. That is also less than 0.01. If it is less than 0.01, the result is significant. So the variation in the marks obtained by students in auditing subject are also varying according to gender. So gender plays a vital role in determining the marks. Whereas you look at the specialization, marks in corporate laws, p-value 0.841. It is greater than 0.05. So it is not significant. That means the difference in the marks in corporate laws do not vary significantly according to specialization. Then next one, 0.289. That is also not significant. Marks in auditing do not vary according to specialization. But when we come to interaction, it is 0.02, less than 0.05. So marks in corporate law varied significantly according to gender and specialization. Marks in auditing also varied significantly according to gender and specialization, because p-value is 0.023, that is also less than 0.05. So what we understand? In the univariate, we can go for only one dependent variable. Suppose marks in corporate accounting. See here, gender and specialization. Only one variable we have chosen. Look at here. No. So marks in cost accounting, corporate law. And we have chosen auditing only in this case. Okay. So marks in auditing varied significantly according to gender. Gender and specialization. Look at here. For gender, p-value is 0.000. The same result. 0.000. Then for gender cum specialization, it is 0.20. Here it is 0.20. Specialization 0.841. Here also 0.841. So this is for one subject. For another subject also we can do it separately. Analyze general linear model, univariate. Instead of corporate law, we can go for auditing. Again, look at this. We get the same result. 0.001, 0.289, 0.023. Look at here. 0.001, 0.289, 0.023. So in the one-way ANOVA, one independent variable, one dependent variable. In the two-way ANOVA, one dependent variable, more than two or more independent variables. If we are comparing together or instead of performing separately, even the two-way ANOVA can be done as one-way ANOVA differently or separately for each variable, each independent variable. We can do it separately. But in the two-way ANOVA, both of the independent variables have been taken together to understand whether these independent variables have made significant variation in the dependent variable. Similarly, here, two or more independent variables, two or more dependent variables, two or more independent variables, two or more dependent variables. See here, I have shown one dependent variable, two independent variables. Another one dependent variable, more than two independent variables. In the same way, we can go for one-way ANOVA also. One-way ANOVA. Corporate law, marketing, corporate law, and we'll check the specialization. Specialization is the factor. Or first gender. We'll go for gender. Look at here. The same result. 0.000. But we have obtained 0.000. Look at here. 0.000. Suppose if we go for compare means one way ANOVA, instead of gender, we are going for specialization. Okay. What is the p-value? 0.024. Analyze. Compare means marks in corporate laws, specialization. We have compared. See here, we got somehow different result than the previous result. Previously, it was specialization, it was 0.841. Corporate law, it was 0.841. Not significant, but now it is significant. So instead of going for one-way ANOVA, two-way ANOVA separately, we can go for MANOVA. So all the independent variables and all the dependent variables are taken together. Once again, we can look at the problem. So two dependent variables in the scale data, two independent variables in the categorical data. In such a case, we have to go for MANOVA. So understand where should we apply MANOVA. So go to analyze, again general linear model, but this time we are selecting multivariate. So what are the dependent variables? Marks in corporate law, marks in auditing. They are the dependent variables. What are the fixed factors or independent variables? Gender and specialization. So we click OK, we got the results. See here, multivariate tests. I told you pillar stress, Wilks lambda, bottling stress, Roy's largest two. With this also, we can say the F value are given, then P values are given, gender of the students. In all the four tests, it is 0.0000 significant. Specialization wise, all are greater than 0.05, so not significant. Both means all are greater than 0.05, so not significant. Whereas when we compared between subjects effects, we got some different results. So this one is the final result we have to take. So we can write that the marks obtained by students in corporate laws varied significantly according to gender, but not according to specialization. Again, they are varying according to gender and specialization. Marks in auditing also varied significantly according to gender and both, but not varied according to specialization. That's all. So here also, if you prefer, you can check the means. Again, go to analyze, go to compare means. Now, marks in corporate loss, marks in auditing, dependent, gender and specialization are independent. Options, number, mean and standard deviation only. Okay. If suppose you want to include a minimum and a maximum, you can include. Then click continue. Then click OK. Now look at here. This comparison is about the marks and gender. Marks and gender. So corporate law and auditing. Now look at male. Mean score 76.47 in corporate law. Girls 52.60. So when comparing between boys and girls or male and female, these male students have performed better. Similarly, in auditing, average score of male 83.73, female 64.80. That is also less than the performance or average score of male students. Now look at this. Based on specialization, finance, marketing, and HR. Corporate law 70.08, finance specialization students. Then marketing specialization students 67. HR students 51.4. So among these three, finance students have been the best performing students. Least performing students are HR students in corporate law. Again in auditing, 80.58 finance students. Marketing students 76 average marks. HR students 60.71. Look at the minimum maximum. Minimum 39, maximum 95 in corporate law. Auditing, minimum 47, maximum 97. Marketing students, minimum 57, maximum 98. Here 63 and 100. HR 44 and 58. The maximum itself is 58. See here, marketing students, minimum 57. HR students, maximum 58. That is why they have performed lesser than the other students. Then here, auditing, minimum 52, maximum 67. Here, minimum 63. Here, minimum 47. Likewise, we can compare in different manners. Different tests can be applied. So today we have discussed about one-way ANOVA, two-way ANOVA, and ANOVA. In the case of ANOVA, just a recap: one dependent variable, one independent variable. For all the cases, the dependent variable must be scaled at. Two-way ANOVA, one dependent variable, more than two or more independent variables. Independent variables may be having more than two categories. Any one of the independent variables may be having two or more categories. That's enough. If both are having more than two categories, that's also okay. Then in the case of ANOVA, any number of independent variables any number of dependent variables. Anyhow, the dependent variables, all the dependent variables must be scaled data. Whereas in the case of independent variables, there is no restriction. At least one of the independent variables must have more than two categories. That's all. That's all about today's module. I hope you would have understood the concepts of one-way ANOVA, two-way ANOVA, and MANOVA. Thank you very much for your patient listening. Thank you, Dr. Sekhar and his team, for the wonderful opportunity. Now it's the time for you to discuss. If you have any query, you can ask me. Thank you very much.
Good evening, Professor. I'm Kannan from Madurai. As usual, you are really rocking the third day. In spite of your cough and cold, you are able to talk nicely without break. That's important. Without a break. Usually, a faculty member will have a break after 55 minutes, but then you are having a marathon session. That really shows the commitment that you have towards the subject, and you are the well-wisher of all the research scholars. I really appreciate, Professor, but I have a couple of doubts, which I think others can also be benefited. Number one, in your example, two-way ANOVA, the interaction was not significant, and therefore you have proceeded further. In a two-way ANOVA example, the interaction is not significant. What happens if interaction is significant? Are we to stop the process, or can we proceed further? That is point number one. In connection to the similar manner for the MANOVA test, what happens if the Wilks lambda is not significant? Because I've read some literature that they say the Wilks lambda should be significant, then only you can proceed further. The interaction should be significant. So some confusions is there probably. As a learner, Professor, if you can highlight on us, I think probably along with some other colleagues, I'll be also benefited. Thank you. As usual, I really appreciate your efforts, Professor.
Thank you very much for your valuable feedback and the important questions. Usually, in the case of two-way ANOVA or MANOVA, I told you, two or more independent variables are there. It is not always necessary that both the variables should influence significantly. It's not necessary. It is also not expected. What about interaction? See, let me show once again so that you can understand easily. Look at it. See here. What is the p-value in the case of retailer? It is 0.569, greater than 0.05. Here, it is less than 0.01. See, obviously, you look at the interaction. It has come down. It has come down because of the effect of zone. Earlier, when we compare to the retailer alone, it was 0.569. But zone-wise, the p-value is 0.000. But when we compare together, it has come down. So if this value, for example, p-value of retailer alone, if suppose 0.142 like that, just for example, I'm telling you, the interaction might have been little lesser and maybe less than 0.05. In that case, it could be having significant impact. So that interaction is based on both the variables, retailer and zones. So that is why the other case, in the case of MANOVA, you look at the results. See here, gender-wise significant, specialization-wise not significant, but again interaction-wise significant. Two-way ANOVA said first one not significant, second one significant, interaction not significant. But here, first one significant, second one not significant, but interaction is significant because of the value, because of the sum of squares that may have given some impact. That is why interaction is significant here. So, in the case of interaction, that significance or not is determined by the significance of all the independent variables. So that is why if it is lesser, the independent variables, one, see here, gender is the number one independent variable number one that has made significant impact. But specialization has no significant impact. Whereas both means we have significant impact. But here, look at this. No significant impact, again, no significant impact. So it is based on the independent variables, not based on anything else. And it need not be significant or not significant. It is determined based on the values of independent variables. That's all. So in one case, we got not significant for interaction. In another case, we got significant impact in the case of interaction. So that is the answer for your first question, Professor.
Thank you, Professor. Thank you very much. Thank you very much.
And as you said, your second question, you come to Wilks lambda. There are 4 tests. Mainly Wilks lambda is taken. Most probably Wilks lambda, or sometimes the other 2 also, first and third. Wilks test is also taken. Watling's test also is taken. Most probably Wilks lambda is taken. Suppose, see here, look at the p-value of gender. All are having the same values, same p-values, but specialization, different p-values. Interaction, same p-values. What does it mean? It need not be the same. At the beginning of the MANOVA test, I told you, no, it need not be same. So in one test, it is significant. For example, Wilks lambda, gender is significant. Wilks lambda, gender is significant. Suppose Pillai's test, gender is not significant. Maybe. In that case, you don't bother. If you want to stress that it should be significant, then you can take out of these 4 tests, which one gives the significance. That's all.
Thank you very much, Professor. Yeah, I got some ideas. Anyway, I'll look into that and I'll try to equip myself. Thank you very much for the concern that you are showing on us.
Thank you, Professor. Thank you. Dear
Sir,
friends,
thank you, sir.
Thank you, thank you, thank you. Any other questions, sir? Okay. Any other questions?
Thank you, sir. It was a wonderful question, wonderful session for all of us. Anova
Thank
and
you.
Manova was like, really difficult, I thought, but you made it very simple. Thank you, sir.
Thank you. Thank you, madam. Thank you. Thank you. Segar sir.
Yes, sir.
Sir.
Thank you to everyone who is actively participating in the entire session today. We hope you all will get some knowledge about ANOVA and MANOVA in today's session. We expect your all active participation for the remaining 2-day session. Thank you, one and all.
Thank you.
Professor Dr. Kumareshan, you made a wonderful, amazing presentation. Every day you are flourishing like anything.
Thank you, Professor. Thank you. So tomorrow we will discuss about ANCOVA and MANCO.
Thank you, sir.
Thank you. Okay, good night. Take care.
Thank you, sir.